everybody. My name is Arun Gupta. I'm the Vice President and General Manager of Open Ecosystem Team at Intel. Containers change the way we build and deploy applications. 10 years ago, it was a very fancy concept, and it was just going dramatic. It still is, but it's so much in a plumbing layer that it's a given these days. And I cannot be more excited to have somebody who was smack at the forefront, who built this whole phenomena, created the tipping point for containers. Solomon, I'm super excited to have you here with me on the conversation.
Thanks so much for having me.
Absolutely. Well, let's start with the introduction. What is your connection with Docker?
Well, I'm the founder. I spent 10 years of my life working at it, from 2008 in my mom's basement in the suburb of Paris, France, to 2018, where I stepped down as CTO and took a long and very enjoyable break from work in general. But yeah, 10 years of building this container tech and using it to change how applications are built and deployed.
What made you think of, I know you were working for .cloud at that point of time. I still have that T-shirt, by the way.
Yeah.
What made you create Docker? What was the pain point during that time? And I love that Docker. And I've heard that story multiple times. But tell me more.
Yeah, so the Docker, the company started out under a different name. It was called .cloud. And that's what I was working on in my mom's basement. But it was always about containers and the potential of that tech that was emerging out of the Linux kernel. And itself was inspired by earlier work by Sun on their operating systems, and IBM before that on their mainframes, et cetera. So it was not a new concept, but the implementation of that concept in Linux, combined with the reach of Linux and the really exciting ways that Linux was being applied, specifically this new web revolution and the beginning of what was soon to be called cloud. That was just all really exciting to me as a young engineer. And so I started a little company to explore it, to pursue it. And originally we were called .cloud, and we focused on using the tech to take care of everything for developers. So it was a platform as a service. And so we would deploy and host the applications for you in a magical way that seemed much easier and more scalable than the alternatives. And under the hood, our secret sauce was this container tech. And then later, we realized, it's difficult for a small startup to capture this huge opportunity on our own. You can't get the whole world to host their applications on your little startup's platform. So after a few attempts, we decided to open source the tooling, open source the tech, and try to create a standard and convince the rest of the industry to join us in building an ecosystem that we would be one participant in. And so that was the pivot to Docker and the launch of Docker, the open source project, in 2013. So for me, it was halfway in. It was 5 years in already. Right. And then the rest of the story is better known because Docker became, it was the right thing to build at the right time, in the right place. And so then it grew rapidly from there. But the focus on container tech and how to apply it to change how applications are built and deployed, that was always sort of a personal obsession for me.
That's fantastic. And what I see, well, first of all, thank you to Mom, because she let you work in the basement.
Yes.
So moms are great. The second part is, it seems like somebody was priming the pump for you. Cloud was exploding. Developers were feeling this pain. These technologies were happening in pockets, but there was no tipping point. Docker is what I say. Docker created the tipping point, which commoditized that whole aspect of let's break the impedance mismatch between dev and prod.
Yeah, I think the way I see it, big tech companies that have enormous engineering and science at their disposal build amazing tech to achieve their goals, big ambitious goals, and you have these big battles. And then out of that, there are byproducts, and these technologies, if you invest enough engineering and research into capability, then the applications are wider than what any one company, even the largest company, can focus on. And then you have sort of these droppings on the floor, it's like a gift from above, And then I really think one of the jobs of startups and independent innovators that operate outside of these big organizations is to figure out what else could be done with this tech, right? So that's what we did with containers, It came out of these big investments in the web and in cloud. And we just felt like, okay, this can be applied to help developers in a different way that no one is, that's an angle that no one is quite looking at right now. And it was really about, democratizing it, not just if you're at Google or a large tech company building a giant web product, like these large companies had a lot of this tooling internally, but they weren't thinking about how to democratize it, And that's, we were the little guys on the outside thinking, well, how do we enable everyone else to use this?
And I'm super excited because the little guys became pretty big, pretty fast, actually. So,
Yes.
And I'm a very proud Docker captain for many years. Fast forward today, as developers are building Gen AI applications, the LLMs, the smaller LLMs are on the range of few gigabytes.
Yeah.
They are packaging those as Docker images, and there are a bunch of other things. When you're building a RAG chatbot, like a Gen AI application, you have multiple components, embedding, retriever, re-ranker, LLM, vector database. They're packaging them as cloud-native components, as Docker containers. What challenges do you see as developers are building Gen AI applications, particularly with Docker?
Yeah, I think it's a huge challenge. It's a major change in the stack. I think containers are more relevant than ever, but I don't think blindly applying the same tools and practices that we figured out together is going to be enough. I think I like to talk about the software factory, like that's everything that you have to do in an automated way to ship the code, assemble and deploy the finished product, right? There's build and test and deploy. There's a million little steps that you need to automate and combine. And so as the product that you're building evolves, the factory has to evolve also. And I think as an industry, we have a software factory problem. Like the factories we have, they slow us down. So there's a velocity problem. And velocity is not just shipping the next feature fast. That's one dimension of it. You need automation. You need to be able to run fast in a straight line. But velocity is also agility. It's the ability to adapt to changes in your ecosystem, to new capabilities, and adapting to the emergence of these amazing Gen AI capabilities. That's a perfect example of an agility problem. I was shipping fast before, but now I need to add this AI feature and everything's different. And so everyone, I think, is trying to re-engineer their factories, and containers are relevant, like I said, but I don't think we have figured it out yet. Yeah.
I think the agility is a big part of it because nobody wants to wait for multiple weeks or months to deliver their feature.
Yeah.
Containers help it, but how do we make that happen? And I think what I want to take it to the next section of the recording here is you have taken that passion of yours of being able to help developers be more successful in delivering apps to your next gig, which is Dagger.
Right.
So tell us, what is Dagger?
So Dagger is a new startup that I co-founded with Sam Alba and Andrea Luzzardi, who were very early employees at Docker. So we sort of brought the original band back together. And it is also based on applying container technology to the next set of problems. I think, so I guess this will end up being my lifelong obsession with container tech and how to apply it. I would say the first wave of containerization focused on the application itself, a new way to build the application and deploy it. So now applications are containerized. Not all of them, but I'm going to say most of them.
It's pretty reasonable default that you will have a container on the Docker hub or somewhere.
Yep. But the factory that assembles the app and ships it into the world, that factory, like I was just saying, it's becoming more and more complex. And at the scale that software is at now, it's kind of breaking down. And it's reaching a point where the factory itself is software. It's automation. So someone's writing the code for this factory, and it's a custom factory. Every product has its own factory. You don't buy an off-the-shelf factory at the store, right? And so the Dagger came out of the question: who are the engineers building these factories, and how are they doing? Can we help them? And the answer is, they're the DevOps community, right? They're DevOps engineer, infrastructure engineers, and they're really struggling. They're having a hard time because they don't have a proper platform, and in particular, they cannot fully leverage container technology to build this factory, right? So the application is containerized, the factory is not containerized, and it suffers from a lot of the problems applications used to suffer from, like they're not portable. You're kind of stuck in one proprietary platform, and you can't easily replicate it. So, for example, a developer on their first day will typically take a long time to be able to participate and ship something because the environment is not fully replicatable. There's a lot of basic problems that have not been solved, and this new wave of Gen AI capabilities is making this problem very urgent because the factory has to now adapt, quickly to the new capabilities and ship very fast. So Dagger is applying container tech to upgrading the software factory, basically.
So today, the way we think about software factory, people push to GitHub and they pray. It's a push and pray, right?
Push and pray.
That, okay, hopefully it'll work.
Yeah.
And if it doesn't work, it'll tell me what's broken. And then it's upon me to figure out what is broken. Mm-hmm. How are you attempting to solve that problem, applying containers? Because you have done that at the application level, but now you're bringing it down to the factory level. So give me more details about that.
So usually at the middle of the factory is what we call CI, continuous integration, surrounded by many, many scripts and tools kind of cobbled together. So it's a factory that evolved organically out of the original artisanal workshop, and then fast forward a few years and things got a little crazy and there's more people and more users and, you can still see the workshop, but there's sort of this mess around it as you try to automate it. And so everything is just kind of locked into place. And so push and pray is really this problem that emerges when an engineer on their local dev environment, on their laptop or PC, whatever, wants to make a change, and they want to run the pipelines that really make the factory. It's just pipelines, build, test, deployment, et cetera. And they can't do it locally because there's only one place it can run over there in the original server or the original cluster. And so they have to do what you described. They commit the change and they push, and then they wait for the machinery to, like there's picture steam blowing out and crazy things happening, and then you get the result. It's kind of like the early days of software development when you had to bring the punch cards, you know, or you had to wait for your time slice on the shared server. So it's a huge contrast between the development experience of the application. So the developer next door is moving at lightning speed, right? Change the code, check the results. The inner loop is incredibly fast. But the poor DevOps engineer who's in charge of, the pipelines, upgrading the pipelines, they can't do that. So we try to solve that by saying, here's something you can actually run locally. It's like a little version of the factory that runs locally because it's in containers. It's portable.
So you're again trying to bridge that impedance mismatch with the DevOps versus the developer. So whatever is running actually in DevOps, you're bringing that as part of the inner loop cycle, essentially on the local laptop.
Exactly.
And that helps with improving the agility.
Yes, exactly. And the the key is that there's this artificial distinction between the developer's inner loop and then the infrastructure or DevOps work. Like somehow they're decoupled. But so the theory is the developer can work on their code really fast, that's normal. And the factory should be slow and difficult to change, it's infrastructure. But in reality, if you look at physical products, there's actually a really tight integration between the design and development of the product itself, like a car, right? A prototype of the Tesla car, and the manufacturing process. Those two they don't happen in a vacuum, right? You're prototyping the car, and at the same time, you're prototyping a new manufacturing process for that part of the car. You're thinking about how much it's going to cost, how quickly you can. Oh, we're going to need a new robot to do this way. It's tightly coupled, and the best software teams want to work that way. But if the inner loop for the app is 1 minute, and the loop for the pipelines that will assemble and ship the app is 1 hour, you can't tightly couple it, right?
It's not it's a mismatch right there itself.
Exactly, that's the mismatch you're talking about. So we just our goal is to turn that 1 hour into the same 1 minute so that you can iterate as fast on every aspect of the product. And when you enable a team to do that, something magical happens because the whole team is now iterating together in an integrated way. And this factory, instead of being this big separate thing that you kind of dread interacting with, it becomes an enabler, an accelerator.
So what happens in that case? Like, I have the factory running on my local laptop. What happens to the factory out there?
So it becomes a choice, just like containerization. It's portable. So you decide. It's about now picking the right tool for the right job. So now you're talking about processors. You're talking about which piece needs a GPU cluster or not. Which piece should be close to production data that's sensitive, right? And sometimes you realize, you know what, my laptop is powerful enough to run all of this. And this needs a cluster. Oh, and this is cross-architecture, so I need to farm this out across these 3 different architectures. And then you have a much more fine-grained vision into what workloads to run where, because they are workloads.
Right.
Right? Because a factory is just lots of pipelines running all the time, and each run of one piece of a pipeline, that's a workload. Right. But if you think of all of it as this giant trapped thing, then what happens today is that people just run the whole thing. They throw money at the problem on really expensive CI servers that are both still slow and somehow underutilized. And meanwhile, your super powerful laptop is just sitting there, also underutilized. So containerizing it and breaking it down into containerized components, as opposed to, it's not about running the whole thing in one Docker container.
Correct.
That's where the current generation of tooling kind of is limited. These pipelines are very modular, right? So you containerize all of them, and then you decide, what should I run on my laptop? What should I run in this giant cluster? It enables, I think, a lot of very powerful scale-out capabilities also.
And I think it kind of brings back the point that you were talking earlier. Laptops are very powerful these days.
They are.
Like, a 64 gigabyte laptop is not uncommon. Yep. So there's a lot of memory, a lot of processing speed sitting on it.
Yeah.
Might as well leverage it.
Totally.
And give you quick feedback. What is a developer experience? So like, let's say I'm a developer who joins the team. I'm firing up IntelliJ. I'm spinning up an application over there, and I want to build an application. What would that look like? Because today, I can hit some button on my IntelliJ, and it compiles the code and tells me, how do I extend that experience to incorporate Dagger as part of it?
So since Dagger really, the way you incorporate Dagger into your workflow is by installing this tool that just runs containers. And then it's programmable. It has an API. Making it API first was really the key, because you make it accessible to developers. So Python developers want to automate their pipelines in Python. Right. Go developers in Go, et cetera. So if you have an API, and you can orchestrate your pipelines out of containers, and the orchestration is done through an API, the Python team does that in Python. The Go team does that in Go. So that's that's how each development team interacts with Dagger. They install this tool, and they just incorporate it in the workflow that they know. So if you use the same IDE, the same server provider, the same laptop, of course, the same build tool chain, you just sort of glue it together with these little pipelines using Dagger. That's the priority, to adapt to the tools you already have. If you remember the early days of Docker,
Right.
it's the same thing we did back then.
Yeah.
There were a lot of platforms that aspired to revolutionizing how you develop, how your application works. Some of them used containers, but they all required that you adapt to the tool, you adapt to the platform. You have to be worthy of the platform. And what Docker did differently was, we said, it's just a tool, just fit, the tool will adapt to you. And the Dagger is the same way. It adapts to you. And then once you wrote this little piece of code that describes your pipeline, let's say this is my test suite, fully containerized, you run it locally, and if your laptop can't run this particular piece because it's really too much compute for one machine, or it needs specialized hardware, then you find the infrastructure that can run it, maybe with the help of your infrastructure team. And then you say, here's the tool, here's my little module, and it's containers. So the only requirement is I just need to be able to run containers. So,
and that's a pretty given these days,
Exactly.
We don't care whether it's running using Docker Compose or Kubernetes, what kind of composition you want to do on top of that. I'm just handing you a container. I have done basic testing here, but you want to do more advanced testing in prod. Here you go, my container, and go run it.
Yep, exactly.
And I remember your DockerCon keynote, from many years ago, where you said Docker wants to get out of the way. We just want to be available everywhere. And I think that's exactly the same philosophy that I'm seeing here as well.
Exactly. And I think a lot of this is, things that if I were to sell Docker, I think I would just be building a Docker. But one thing we learned at Docker is at some point you need to focus, because one company cannot build everything. Right. Pipelines are just unique and different, and containerizing pipelines and the whole factory built around these pipelines, it's just different from containerizing a web application or an application backend.
Right. What role does Daggerverse, Dagger Cloud, they play together in this ecosystem?
So there's a whole platform. We have the engine, which is this tool, this open source tool that you can program, and there's because it's programmable, there's a developer ecosystem around it. And it's really interesting because it's a cross-language community, right? There's a cross-language ecosystem and a cross-language developer community. There's Python developers, Go developers, TypeScript, et cetera. And they all have in common that they have a factory and they want to improve it, and so they're writing these little bits of code to automate the factory the way they want it. And the key innovation that really enables this community to thrive is we enabled cross-language reuse of components. So if I write the perfect component for testing a TypeScript application, that component can be reused in a pipeline that's written in another language, right? So teams can collaborate, and the whole DevOps community can collaborate also. So the Daggerverse is our fundamental name for the search engine that lets you find all these modules that the community open sourced, basically. Since it's code, it's probably in GitHub or GitLab or some other code collaboration platform. We don't host it, we don't centralize the hosting of it, but we help you find it. So that's Daggerverse.
And I think the beauty of this is, as you said, I could have written a module in Go, but that could very well be used by somebody in the Rust or the TypeScript community, because at the end of the day, it's containers.
Yep. It's containers, and what the Dagger engine does on top of that is it has its own unique API to orchestrate these containers into pipelines in a very powerful way. So the individual container is the building block, but a Dagger pipeline is a dynamic, it's a DAG, really. So it's a graph of individual tasks, each running in a container. And it's all orchestrated dynamically through the Dagger API. And then the Dagger API is controlled by your code. And we offer SDKs in many different languages so that you can control the same Dagger API with your language of choice. And now there are language communities that show up in the Dagger ecosystem, and they say, well, we want an SDK also. And so there's a way to contribute your own SDK. So for example, there's a very active group of PHP developers that want a PHP SDK for Dagger. We didn't have the resources to develop it ourselves, but they're developing it now, and it's working. And they're bringing their friends from the PHP community saying, you've got pipelines, you've got a factory. What if you could program it in PHP, but instead of being stuck in the little silo of the DevOps-aware PHP developers, what if you could reuse all the work that the DevOps community in general already produced in Python, in Go, in TypeScript, et cetera. So there's a sort of the compounding network effect.
Right.
Yeah.
Right. No, I think that's amazing, actually. And what you're doing is really simplifying that entire software supply chain, improving the velocity, improving the agility, and no longer push and pray, because you have done that work on your local system, essentially.
Right.
And by the time it gets up in the cloud for full integration with the system, there is a much higher level of confidence, essentially.
Yeah, exactly. It's all about velocity in the end. People want to move fast. They have an idea. They want to ship it fast. And our job is to remove obstacles that are in the way of them shipping fast. That's really all it is.
Let's pivot a little bit. How does it help with the DevSecOps movement? Because the vulnerabilities, if people are building open source, closed source, are only going to increase, or only increasing. There are new kind of engineering attacks that are happening all along. How does it help with the broader DevSecOps movement?
I think, so in my little framework of the software factory, I think of DevSecOps as making sure the factory is secure. And also, your upstream suppliers are secure because a factory is part of a broader supply chain, right? And so you've got inputs. Are these inputs the ones are they trustworthy, et cetera? So we have technology now and point solutions to do things like scan artifacts, sign them, trace who touched which artifact, et cetera. And now we even have standards and I think the beginning of a regulation momentum to require that these standards are used. And so overall, if you zoom out, that's great for the industry because we've started a process of making our supply chain more secure. The way we contribute to that, we don't develop point solutions for security, right? We don't develop a scanning tool or a tracing or signing tool. But there's a limit to what you can do with these tools today, and that's visibility into the graph, what we call the DAG, right? So it's great that you can sign artifacts, but how do you know for sure that you know which artifacts are out there, and can you model the actual path they follow? The problem is all these factories are built today on they're all like an ad hoc accumulation of improvised automation, and it's all built on shell scripts. It's all built on old technology that's cobbled together. There's no unified platform that can tell you, here's what's going on, end to end. Here are all the pipelines, here's the DAG. There are islands, right? You can go and maybe you're using, if you use a CI product, your CI has one picture, like one piece of the graph, and maybe use a build tool, like maybe Gradle or Bazel or Make or whatever. That build tool has another view of their island, but usually there are many islands,
right.
And the interconnection is just, no one knows, right? So what we're trying to do with Dagger is provide a standard a modular standard for the whole factory. So you can containerize all the components of all the different islands that you have. You don't have to throw them away. Still the same build tools, still the same tool chains, but they have in common that they're going to be running in containers, and those containers will be orchestrated by the same API. And then you can ask questions like, show me all the artifacts and show me exactly how they were built. And then you have an injection point for those technologies, those point solutions.
Beautiful. So I think what you're saying is, instead of having a duct tape and chewing gum to put this thing together, it's a bit more streamlined and very clearly defined injection points, which is enabling partners to make the pipeline more secure.
Right. Yeah. Imagine someone invents an incredible new robot that will make your factory, like it's a scanning robot that will take any artifact that flows through it and scan it, and it'll be perfectly secure. But then the whole world has 19th century steam-powered factories or manual workshops. What are they going to do with your super powerful robot? There's nowhere to plug it in.
Yeah.
So we streamline the factory itself so that you can plug in the super powerful robot, and you can start actually upgrading it.
My God, I can keep talking about this forever. I want to go to my last question, really. Okay. With all the innovation that is happening so rapidly in the AI space, I would love to hear your views. We are seeing open source models, we're seeing closed models. We are talking about responsible AI, ethics, bias, all sorts of stuff. What's your view in terms of what would make AI more successful, open versus closed?
Oh, wow. I honestly am very curious to find out. I don't know. I think it's great for everybody that there's this competition going on between these two models. I mean, more than the two worldviews, because I can't say model anymore. The open worldview and the proprietary API-driven worldview. From the developer's perspective, what we're seeing is that they're getting the benefits from the competition. Like, competition means lots of cool features and lower price for the developer, which is great. But the challenge they have is they kind of have to hedge, and they have to be able to support both, actually support multiple models and also multiple architectures for consuming the models. And we see that in our space. We see software teams and AI teams assembling these pipelines to automate the delivery of their applications, and they need that piece, the model, to be swappable.
Right.
Like a very common case that we see, we have some Dagger knots. We call them Dagger knots, in the community. And so they're building these pipelines, and they interact with models, and they have two different versions. A version that calls out to the latest hosted models to get kind of that one new feature that was shipped 2 weeks ago, and then they iterate on that. Their inner loop is on that. And then in parallel, they need a version of that calls like the in-house model that's authorized to touch sensitive data at work. Right. Sometimes they even do this on 2 different laptops. Right. But eventually what they want is to not have to develop the whole thing twice. So what they want is develop the logic once and then make sure I don't have to commit to open or closed now. I think they want both. So I think both will continue to exist for a while.
And that has been the norm, for a long time. Over a period of time, open has definitely become a lot more prominent. So I think it's anybody's guess, but I think there are advantages of both the open and the closed. At Intel, we fundamentally believe open is the way forward, and that's sort of what we are heavily betting on. But I think it's an exciting ride.
Yeah, you're not alone. There's a lot of very smart people betting on open. Yep.
Thank you. Well, Solomon, I really enjoyed the conversation today.
Likewise. Thanks so much for having me.
Thank you so much. Thank you so much. This is Arun Gupta. I really enjoyed the conversation today. We talked about how Docker came about to be. Then we talked about what Daggerverse is, what Docker Cloud is, how Dagger is simplifying, your experience of bringing that inner loop, making you more productive, improving your velocity, agility, and not go by the push and pray mechanism. And we finally concluded our conversation by talking about open versus closed. That's the unending debate. Thank you very much.